Good evening. Hello, good evening. This is Engineer Suraj Singh speaking from Bharat, India regarding mathematical formula composing on spreadsheet, direct demonstration, and title of this talk is Mathematical Formula Demonstration, Equations, Geometric Shapes, Combinations of Shapes, etc. on this day on 18th December 2020 and various combinations and letters, etc. Previously also we have given certain demonstration, and this file you can see here. Purpose of this purpose of this sheet is that how to generate simplest to complicated formulas. Formula generation plus validation by me, that is Engineer Suraj Singh, Chartered Engineer, Fellow of Institute of Engineers India and International Professional Engineer. I last talks gave you many such formulas, equations, and also we talked of certain engineering formulas, trigonometrical functions, and it's now certain geometrical shapes also, that were square, rectangle, then rectangle, of course, triangle, ordinary triangle, equilateral triangle, and isosceles triangle, right angle triangle, triangle with three sides, and circle, then shape, sphere, cylinder, cone, parallelogram, sorry, parallelogram and rhombus, then trapezium, both symmetrical and non-symmetrical, then polygons of various dimensions like number of sides, five-sided pentagon, then six-sided hexagon, and then seven-sided heptagon, and then eight-sided octagon, and nine-sided nonagon, and 10-sided decagon, and then triangle. The combination started with triangle and circle, and also right triangle and square, and then you can say triangle in parallelogram, and after that it was right right you know right angle triangle in isosceles triangle plus teeth out right angle, and later it was five-sided polygon pentagon construction around square, followed by combined five-sided polygon pentagon constructed around isosceles triangle. And then I think I'll open this better so it's clear. And it's so it was, you can say, combined right angle triangle and isosceles triangle, teethed out right angle triangle, and then it was five-sided pentagon constructed around square, and then similarly five-sided pentagon constructed around isosceles triangle, then hexagon constructed with eight-sided, and later on it was polygon pentagon constructed with eight sides, and then it was, you can say, polygon pentagon constructed with 10-sided decagon, and it's that, and also combined polygon decagon, three number five-sided pentagon on one number isosceles triangle. I'll show you these sketches as well. And then cruciform, Shakti, David Mark. After that, swastik plus cruciform, and swastik cruciform together separately. Then swastik numbers, one number inside and six number outside Shakti Davids. And then we have here, you can say here octa motif, which is now we are going to chart out octa motif. can say octomotive is there. Very complicated one actually. You can see this one. Octomotive. Octagon it is, means there is 1, 3 here, 2 here, 6 corners, 8 corners. Actually, there's a rectangle, a square here, and a square here, 45 degrees to this. There is one circle here, there's another circle here. It's connected here like this by some passages or something. So we have these isosceles triangles around like some kind of shield, you can say, shield. And here we say this is A and this is A. Octa means 8, and this is dimensions are mentioned here. Some kind of circle here with width, another circle here with width, and this a kind of decorative motif design, ornamental design, you can say like that. This is last time we did all this in part, and this is star. We did last time, this is star. We explained to you star and also swastika, and this was David or Shakti, and this is one swastika here and David or Shakti here, and then swastikas around, as well as you can say this is line of Shakti David, line workout, and then it has can say swastika and cruciform combinations, and also separately this cruciform itself and swastika here, and like this previously many shapes were there. You can see these shapes all are here that we worked out. It was all that, and various shapes you can see worked out like this. All this have been worked out, and you can say this is a kind of mathematical come engineering work, I can say, where we are trying to find generalize certain shapes for purpose of use, and that's all purpose behind this. So we go back wherever, we go back here and come here again. This is what I'm talking of now. What says that there are isosceles triangles here, 8, and there are 8 according to this 8 item, this one, and then here circle and the circle, and these steps, smaller step and larger step, like that in this. This is A and this is A, and this is we can say A over 4, width of this is shown here, and A over 8, 0.75 A over 4, and this A over 8, this A over 4, and this dimension is here. We are considering A, and A. So it's A over 2. So you say, if you want to find something here, you can say under root 2A, like this. So this is, you can say a kind of motif. I'm saying the combination is this. This is equal. This is full angles, isosceles triangles, and this is right angle here. Well, this is a right angle here. This you can say is a right angles here, and there are two combinations. One is isosceles triangle with a combination of right angle, and we have worked out that angle without any problem because this is 45 here. So I'm sorry, this is not 45. 45 is here. This is for this one. This is right angle 90, circular triangle, and then the circles are here, and then steps. That's you can say. This is what we have done. I have to see that one. In this case, we have, and before that, if I just want to give something additionally to you, is letter A. You can say this is letter A. I mean to say this is letter A. A, B is like C, D, and also E, F, G, H, I, J, K. I had to do LMNO peak to all, but I've done only this one I have done so far. I just want to confer with you about this, which is very crucial work, crucial in a sense that it consumes time and it's not that easy as you think. So we can say, let's do this. This work here, motif work. Motif and followed by motif is this star sign with 5 corners. We have just taken strip in this. Before we showed the star only, but now we have taken strip here to find its area. So let me first do this motif here, and we have to understand this very well. What it says, that's point here, what it says. Now it's saying the 8 corners, there's requirement of isosceles triangle template of application, and there's a requirement of right angle triangle application. There's a requirement of circle, and there's a requirement of rectangle, and all dimensions are of course in meters. That's very much true. And if you take it like that, you can understand it's a very long step. In fact, let's say there are 8 isosceles triangles, and equal angles means isosceles triangles. Height of this base, height of this triangle is h, small h. Area of one number isosceles triangle we have to find, and the number of isosceles triangles which we have to multiply with. So area of 8 number of isosceles triangles is this. So let us see. First of all, this is we have a right angle. Isosceles triangle is base is equal to a over 2. What I am saying, because you see this base over 2 is equal to this. We say now. Yeah, it says this is a base here, and it says this is here. I'm considering this, if you take this height we have and base we have. So this is, A here, and if you see this, you'll find that one, what we've done, that base is B, that is, you can say, like this, okay. Let me just blow it up. This is, 2A here. This is 2A. It's at power 0.5. How to find this? How to find this? That. If you consider this A and this A, this is A and this is A. So A here and A here and A here. So what is this? We want to find this. This we got some answer. That is 2 to power 0.5, because A and A. So we get A square plus A square. This is 2A square. So we got this value as, A over 2. That is here. Now we can say that height is 1 point. That's E543. First of all, we can say half into base into height. This is half into base is C563, and this is C563 1 and D563. This is height is this. So we got this value, and we can just reduce this value to 2 decimals, so that it looks nice, and we can say here. Now 0.5 into this half into base into height. We can say here this value of h square, and this value, because we are going to find hypotenuse of this triangle. Hypotenuse we have to find, then we can say this is b, so this is half b here. We can say half b into h, so 0.5b whole square is this one, h square this one. So hypotenuse is this square, half base square is half base square plus height square. This we get hypotenuse by under root of this. Find this, we get this square plus this square, under root we find this. So let's say 0.5 into b, so 0.5 into b power whole to power 2 plus h to power 2 and whole to power under root 0.5. We get hypotenuse is 1.62. Now this is hypotenuse. So parameter is equal to this base plus 2 hypotenuse, this base plus 2 hypotenuse, it is parameter. So b plus 2 into h. This is b plus, that is 2 into h. H is hypotenuse here, that is h, which is hypotenuse. I can write h here so that it be clear actually. Let us say it's h here, let it be clear. H is equal to, so this is b plus 2h. One h this side, one h that base. So this parameter. Remark is open cell now. Come on. So I think, alright, now it's an isosceles triangle because we are using this triangle, isosceles triangle, and it is connected to that one because here we are seeing isosceles triangle and it's being used here in, you can say this summarize here. Actually there are so many, you know, if you see here combination I'm trying to find here, and this is that one, is octamotive. So what I'm saying is, in this case, that was for isosceles triangles, but it's for octamotive, 8 corners required is triangle required, and then you can say multiplied by number 8. So we can say here is base is this one, half of a2, and it is equal angle 75, tangent 75 is this, and perpendicular height of base equal to this. So area of one isosceles triangle is, we can take from that template, half base into height, that template is E563, and this is here E563, this is here, you know, E563, which already is there, so we just brought here. Is just understand, for this template we are using isosceles triangle template, or also right angle triangle template and required circle template and rectangle. These 4 we are using for this motif. We are using these 4 formula for this motif. It's very interesting one. Just have a look again at motif and you will find what actually we are doing. First you have to understand this, what it is, octamotif. Very useful. very cold. I just went to take some blanket for me. Very cold, sorry for delay. So you must have seen this. Now I'm trying to tell you what actually I analyzed in this isosceles triangle analysis in this. So I've taken area isosceles triangle, and area of one isosceles triangle is this, and that is here from formula of template. Then number of isosceles triangles 8, so this is 8, and we can take G543 number of triangles into F543, that is area. We get total 8 areas, whatever value here is. Now this rectangle isosceles triangle is over. Then we go to right triangle, and let us say this is right triangle here, which is base is there, perpendicular is equal to there, and all dimension meters are equal angles 45. Here it was 72, here it's 45. This is for right triangle. So other angle is of course 90. Area of one right triangle is this E567. That is from isosceles formula. Area of one right triangle is this. That's from formula because I have connected previous application to this one. So number of rectangles 8. So this is 8 area. This one part. Then we go to octagon within. Octagon within. Though I'm just giving area for information, there is no meaning because that's just a line. Then circular path. That's important here. Circular path. Width is A over 8. That is A is, as usual, we have taken 2, and that is A over 8. And small radial, that is A over 4, and radial width is A over 8. Big radial is 1.5, it's 0.75A. Big radial, so which is big and small. You can see here, this is small, and this is big. The 0.75A, and this A of 4. A over 8 is width. This is general here for this. So that's what I'm saying here. So we're talking of, so equal radial width is this, big circle 2, this small radial small. You can say one is big circle and one is small circle. We're talking a big circle, and big circle is this one. This one is big circle. In this big circle, we have this diameter 2.5A, which is there 2.5A, written on diagram. This is 2.5A, that is plus A over 4, because we have to see center of that. This is external diameter, so we have to find average ones for that purpose. I'm adding here big circle diameter. Internal diameter is this 2.5A, and this is 2.5A plus A over 4. So average is this area. Average is, average diameter, because we have to find radius. So we have to take average and divide by 2, that is this one. So circumference is this, G572, we are taking from formula. And then big circle width is this, is big circle width. What do we do? So this is width, big circle's area is circumference. When you have circumference, average one can multiply by width, because it's not internal or external, external circumference, it's average one, middle one. Small, now this is about big one. This was about big one. You say big, circular path I'm talking of, and this is what we're talking of this. This is circular path here. Now, Now we go to a small circle. A small circle, you know, we also big one. You can say it is up to here. Small circle calculations. Small circle calculations is very, of course, on same pattern as previous one is done. Says small circle internal diameter, small circle external diameter means internal diameter plus your 4 average radius. Then you can say all these are written. I'll go one by one. Let us say a small circle diameter 0.5a, so this is 0.5a is 1 here. It's like this, and then small circle external diameter is 0.5a plus your 4, and that is this one. Then average radius is sum of these 2.5, and that is this one. And this circumference according to given in your template of what can I say, application formula. A small circle width is here 4, that's just there, and small circle area circumference into width, so we got small circle area. A small rectangle now, this portion is rectangular portion here, all small rectangle, and you can say small or big both, or short or long, whatever you can say, you can call, that's no problem. Now a of 4 is length of that. Therefore, which is this, and that is from, that is here, you can say here, then you can say this is I543, I543 is this base, and we are saying A, so A or 4 is that. So that is small formula. Now, so we have done this now. The small rectangular length is this, and the small rectangle width is this. I'm sorry, where were? Yeah, sorry. Hold on. So this is, 0.5a, and diameter this, sum both, and radius is this. So we got this small circle width. The area is this one, as before it was. Now got area. Now rectangular area, a small rectangle area is this one, is that one, this biggest rectangle here. In this A or 4, A or 8 is width, and approximate rectangle area radial, that's a small one number, A4 into A8 square meter, that's this one. Number of small radius rectangular 8 numbers, area of 8 numbers is this one. Now big rectangle here, big rectangle is here, and we can say that this is big rectangle length is 3a over 4, and big rectangle width is a over 8 as a small one. Approximate rectangular area radial big one is this multiplied by this, and we got this. Then number of big radial rectangles 8, area of 8 big rectangles is 1 into 8, we got this. Now all areas here, isosceles, all areas square meter, this is isosceles plus equilateral isosceles triangle, I mean to say, plus equilateral triangles, the 8 numbers both, plus circle, big one plus small one, and small rectangle and big rectangle, all these are here. So it is here 1, 2, 3, 4, 5, 6, and we can say, as you see, we have put this line here, these areas here, whatever area is here, these are in bold letters given, these bold letters here, again this, and if you go further you will find here, as well as if you move further you will find here, and like that here. So these are area step. So we can say AP547, for example, this is here AP547, AK547, and we can say this is AK547. Like this, if you go this way, you'll find 1.96 as well, that is AF circumference, sorry, the circumference, not this one. This is that I'm talking of area. So let us say area stands for, and that is here n 547 and 547, and that is h here. So these are areas put in here, and we say that total is this 39.37. And if case parameters also we say parameter we take directly on the dot. So we say for isosceles triangle, and we have taken parameter from formula, and 8 for 8 is this one, for 1 is area of right angle triangle, that's parameter of right angle triangle, and that is this one here, and for 8 it is here, and we go further go, we'll find that it's here, and so we got for here 8 number small rectangles and area of 8 big rectangles. Total answer is this. Circumference separately I'm taking because you cannot mix up circumference parameters, that is not permissible because the curve circle. So it's 2 numbers here for to find that, and circumference is this, and sum of both circumferences is this. By taking both, average of these two is this one, and sum of both circumferences is this one. Similarly for other one, this is this one. So we got here areas of all, perimeter of all figures except circle, and circumference of circle. So we got here this 3 answers. This area, this is perimeter, this is circumferences. That's one part. Now other part is one part. Now this is superficial. Now go to 3D volume, that is in cubic meter as well as in 3D surface area that we have to find for this automotive. Sorry, important one. What we did 3D volume is a cubic meter. Area we have here, that's from connection 503 we got link, and from there we got link here, this one, and depth is whatever depth, and we can say multiply by this, we get volume. Of course we got 3D area here for 16 here, that's here, then multiply by this here. Of course then we got here it's 8.55 here. This we get this one, and similarly we got 1.96 and this one. So we get all solid volumes like this based on this. And we got total volume here 1962. Volume is in cubic meters, doesn't matter, but also surface area is an important point. Surface area, which is very important to find surface area, and that one I'm going to discuss. Here surface area also 2 end areas means motif area at top and motif area at bottom. 2 end areas, that is this one, twice into this plus perimeter into this. So we get twice into this area plus perimeter into depth, and we get depth. This is surface area of this item. Then we can get surface area of this item. The 2 end areas plus perimeter, that is, let's say a right angle triangle, that's isosceles one. It's right angle triangle, we got this, this 2 end areas plus perimeter depth, and that's this one. And then we go to here for this is for big small rectangle and big rectangles here. Similarly find this, and we got this one here, 2 end areas perimeter depth and 2 end areas perimeter depth. So we got these results. And when you take up like this, surface area is over, and this is end areas for circumference. This is regarding small circle and big circle, and we can say that so we got this. Well, I think motif is over, automotive is over, and so this you can see formula is expanded like this. It starts here, it goes vertically like that. You can see the combination of previous formula integrated into this, clubbed into this, and we are following this now star sign. What is star sign? You know very well. What is star sign? What we want actually? Star we already discussed, but this is now finding strip of star, not exactly just line work, but strip of star. Strip of star, star, you know very well a star. It is five-cornered figure. Five-cornered figure it is, and five-cornered is that one. It's really very interesting to know this because it's not that simple as you think. This drawing itself is difficult, but it can be done, no problem. You can see that whatever is here is given. Base is pentagon because five sides mean pentagon. And that is then inside. This is 1, 2, 3, 4, 5. And the isosceles here is also isosceles. But here some step where you can say height is isosceles triangle height is h. And as this base is a here, pentagon base is same as this. We have this. This angle is 72 here. So we have formula here for hypotenuse for that. So we can now move on to it's how to do it. We have this triangle here. What we need, we have rhombus shape, of course. No, rhombus where? Here is rhombus. Here is rhombus. There is rhombus. Rhombus and rhombus. So 2, 3, 4, 5 rhombuses as well. So it's a star. This is like narrow work. What you need? You need isosceles triangle and rhombus. Required rhombus. Okay, so we have this. Now start with arm width is M, arm width. Arm width, or you can say strip width, whatever you can say. Base is A and tangent 72 from this angle. This angle tangent 72 you can say is 72 perpendicular upon base is tangent 72. So we have perpendicular to and base we have perpendicular we can find. So we have this dimension with us. This dimension we have, so we can find this, no problem here. So it says h over 0.5a is equal to tangent 72. A is there, width is there, tangent 72 is 3.08 according to formula of tangent 72, sin is this one. Then h is, from this formula we can say 0.5a into tangent 72 is this value, which is here. External side hypotenuse m. Internal side and external side hypotenuse. That's the question here. The hypotenuse means this is here, this hypotenuse and this hypotenuse, both hypotenuse. This bigger one, this smaller one. We have to find this. Right? We take a rhombus separately, so we can say on top of this portion of trapezium, this portion of trapezium, and you can say, you can find that one. This is top triangle here, you can say here. So with that, you can find these values, and here's how what we're done. You see, actually we're done here. You can see here, external side of a square, a2 square. H we have already known. We have the external side of hypotenuse. A over 2 whole square plus h square under root. We got this one, external hypotenuse. We got external hypotenuse. Then internal side hypotenuse. Internal side is internal side hypotenuse is top triangle perpendicular minus bottom triangle base is equal to internal side hypotenuse. Alright. We're talking about this triangle. We have to find this value because we have to know this value. We have this one here. We have this hypotenuse, but we don't have this value which you have to deduct from this to get this. That's what I'm talking of, this one. So here we got this, hold on, yeah. External side is this hypotenuse, internal side is this, that perpendicular minus bottom triangle. So top triangle perpendicular, that is in meters is A over 8 into tangent 72, which is this. So bottom triangle base is A over 8 cot 72. Internal side hypothesis, that's internal side hypothesis 12.68 in this case. So we have external here and internal here. What to do then? This is solved our trapezium for purpose of trapezium. Now rhombus, where to say how to solve this? We got this internal side, this so trapezium here. We have 10 number trapeziums. 10 number trapeziums. I'm to say 10 number, what I'm saying 10 number is this here. I'm talking of this trapezium. This trapezium. This one triangle and triangle, other one is here. Both we have solutions, both we have. So we have to find this dimension plus this dimension over 2 into width. We get one trapezium. Second trapezium like this. 5 sides, 5 corners, 10 trapeziums are there. 1, 2, 3, 4, 5 rhombuses are there. What I'm talking here is 10 trapeziums. Is half into sum of hypotenuse into width is 18.51. That's area of one. Area of one trapezium. Area of 10 is this, of course. Then rhombuses. Dimension is equal to base. So rhombus is equal to A over 8. That's for dimension into cosec 72. We get 1.31. So vertical angle is 18, because 72 is angle, so 18 is that one. Area of 1 is, we got this, by formula of rhombus. So area of 5 is that. So we have individual areas of this. Finish? Now talking of this, we have individual areas of these both. Now we talking parameter of this, parameter of is arm or we may say anything, 10 numbers, and we can take, it is G590, that is here. This is 10 numbers. Parameter, now we say 10 numbers triangles, and we can say actually volume. So hold on, we have seen area here, right? Now 10 arms, so this is area of 1, this area parameter of this is 16 point here, hypotenuse, yes, external side hypotenuse, this is a length 6.94, so 10 numbers is this, you can say G590, okay, so we can say that bottom triangle base is this, number 10 also, inside internal hypotenuse this, then internal rhombus, internal hypotenuse 1 plus rhombus base is this, that is this one, okay, 594, okay, 594 plus C603, C603, that is here, so that is rhombus formula, so we have got this. Internal side, sum of both internal and external dimensions is this, total of all 10 numbers is this, that's your parameter. So we have resolved parameter. Now 3D, we have to find volume and area, volume and surface areas. So volume is 10 meter height, let's say, so it is here, because 185, so 10 multiply, we get this one, and of course area is here, depth is 10, surface area is here, so we can say 2 and areas plus parameter, and that's just this one, 2 and areas into parameter, that we can find from this one. So what we have done, we have used rhombus, and other one in this star rhombus we have used, and trapezium we have used, and we use directly trapezium and okay. Now specifically we are going to a different world of letters now. This was just, I'll take more figures later on. Now I'm just doing this because letters are used often, and it's not that easy as you think. Letters, which is very important chapter here. Letters, everybody knows it, what is letter, but I'm trying to do it in geometrical form. You can see that. Hold on. This is a ladder. A, I have taken this kind of shape rather than other one. I'll take inclined shape also later. I'm just simplifying now because simplification is first requirement. It's saying that there are certain dimensions here. Letter A. This letter A says this is base A. Base A. This is 5A. This is 8A. This is 3A. Like that. Areas 1, 2, 3, 4. So let us see how it works. Because I don't want to calculate dimensions, I want to calculate proportions. In mathematical terms, I don't want to use direct dimension, because when you use dimension every time you have to calculate. I don't take every time. I don't want to calculate every time. I want to just enter base and get answer. That's my purpose of formalization. Yeah. I'm calling this steplet. Now, there are many areas, as we discussed there. Area 1, 2, 3, 4. 4 areas. Area 1 is 5A minus 2A. You can see this is 5A minus this is A, and this I take it A like this, and then different way. You can take your way. So 5A minus 2 is equal to 3A. So area is equal to 3A into A. So this is here 3A into A. Now area 2 is 8A, is vertical one, it's equal to 8 into A. Then area 3 is equal to same 5A minus 2A is equal to 3A. So 3A into A, and area 4 is equal to 8A. That is 8A into A. 8A is one dimension, other one is area A. Area is 8A into A. So these 4 I calculated here like this and added here. Total of 1 plus 2 plus 3 for 4. So we got area of this figure, whatever. Now perimeter. Like this. Parameters we have to see. I'll show you first how we did it. See this, and internal one. Both we have to do and add. So let's do parameter external. That's A plus 8A plus 5A. A horizontal, 8A vertical, then plus 5A plus 8A. You can see this here. It goes like this, this, and next is this, like, So we add A plus 8A plus 5A plus 8A plus A plus 3A plus 3A plus 3A. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. We got this perimeter. External one. Internal is 3 dimensions are there, 4. Are they 1, 2, 3, 4, 1, 2, 3, whatever you think, equal 1. So we say it is, you can see we got internal parameter. So total is both of this. Of course we have both of this. So we have said that. So what is 3D? Now we are talking of 3D. 3D of this, when you extrude this, what happens? That case, extrusion, then say volume, we have area into depth, so we got this, and surface area is 2 and areas plus total parameter depth is 2 and areas is G614. G614 is area, and this you can say 2G614 plus J614, that's here, perimeter into depth, you get that. So this is the result. A is the result. So we come out of A and we go to B. Letter B. This is letter B. Similarly, I have proportioned it. Proportioning is very important. You have to design proportioning. In fact, just like you proportion here, you have to proportion here. That's very important. Let us say, for example, this is, you can see this all the proportion. 5A, 8A, 3.5A, like this. This area numbers are also given here. and these are proportional dimensions in terms of A. No separate dimension, no direct dimension. This is what we are talking about. So we say, okay, now let us say what's that. Letter B has area 1, 2, 3, 4, 5, 6. 6 areas are there. 6 areas. We have to work out for 6 areas. Hmm. 6 areas. Area 1. Proportion is there. Width is there. Area 1, 5A minus 2A, 3A. So 3A into A. Area 2 is 8A, 8A into A. Area 3 is 5A minus 2A, and that is equal to 3A and 3 into A. Area 4 is A plus 2.5A plus A. Let's see area 4. This is area 1, 2, 3. This is 4. Here this is 2.5A here. So we can say area 4 is A plus 2.5A plus A, and that is area 4.5A into A. And area 5 is same, equal to area 4. So same is written here. Area 6 is 6A minus is 4A into A. This is sum of all these areas 1, 2, 3, 4, 5, 6. We got some C6, 9 here to this one. Now parameter. Parameter external and parameter internal. What we have here? Say 8A, 5A, let's say here 5A plus 3.5A, 5A plus A plus 4.5A plus 6A. It's okay, external parameter. So here it says 8, 5, 3.5, 1, 4.5, 6. We got this. And we got this means we have this answer. Parameter internal. There are two parameters internal. 4A, let's say 4A, 3A plus 2.5 plus 3A plus 2.5, got this. We got parameter internal, other one, this one here, bigger one, 4A plus this and this, we got that. So total, the sum of these two. Extrusion for volume, area, we had area, that's this one here, and this I619 multiply this to get this area, and surface areas 2 and areas plus total parameter, deduct this we got here. So area letter B is gone. Now letter C. Letter C, little understandable. In this instance, what we are showing is very important one. Letter C is very simple one. You can say, just see here, 1, 2, 3 areas are here, 3 areas in letter C. Area 1, area 2, area 3. Area 1 is simple, 5A is a 5A. 5A minus 1A, 4A, and 4A into A. Width is this one. And area 2 is, let's say, 8A into A, and area 3 is, again, same as it was here, so sum is this one. Parameter, you can start here with A plus 5A plus 8A plus 5A plus A plus 4A plus 6A plus 4A. So we got this. A 5, 8, 8, 1, I 8, 1, A 5, 8, A 5, 8, A 5, 8, 8, then 5 is 5, then 1, and then 6, 4, and 6, and 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Got it. And this is what we say. 1, 2, 3, 4, 5, 6, 7, 8. Extrusion is this 10. We have this volume is this area into this extrusion, and two end areas plus total and perimeter to depth. So this is that area. So we got letter C gone. See how fast it is going. Letter D. Letter D. This is letter D. Letter D. Letter D. You can see geometry. If you understand geometry of this, which is little easy and still as difficult because there is no problem in this, but problem is here. Area 4, you can see that. Area 6. This is okay. Now, how will do? We have to take care of this first. You say area 4. The step is there. Area 4, H. What is H? What is H? See, there are two H's. One is H here. This one, H here. Other H1 here. And this is whatever is here, and this is, width is same all about. This is also A. This is also A. We have to solve it this way. A, this arrows are given for A. This is also for A. This is from A to here. So we have to find out what is H1 and H. And area 4. H is A square plus A square is equal to 2A square to power 2 square and 100. That's H. So we say it is here 2A square 100. Now this is one part. A corner right triangle base. What's that? Corner right triangle base. What is corner right triangle here? Here I'm talking of this triangle here. Talking of this triangle here. Small triangle here. So it's a kind of rectangle here. And so there is a trapezium, We are not going to go to the trapezium. We have to understand this first. Says corner right triangle base angle is 68. Corner triangular, other angle is 22. So we know this angle is here. So we say 68, this angle is 22. Tangent is 68, 2.48. Now triangular base over perpendicular is equal to, because the base of a perpendicular is still the cot 68. Cotangent 68. So triangular base is equal to A cot 68. And that is this value. Tangent value I reverse, so that's cot, so this is that one. H1 is equal to H minus 2 base, 2 into base, H1. So that is this value, H minus 2 base. Now, area 4, square trapezium it is now. Square meter, and that is trapezium, because this is trapezium. And now realize we have to find out trapezium here. This trapezium, talking of this. we have got this hypotenuse. We have got this hypotenuse, right? We have this depth, which is naturally we have. So what do you say here? We have h1 and we have area 4 is h1 plus h, sum of this and over 2 into a, and that is h630. That's here. h1 we have, and we have no multiply basically is sum of these two, c630, that is here, h and h1. Then we can find out area 4 by this trapezium area into b630. b630, we know this is width. So we got this trapezium area done, area 4 done. Now area 3, what is area 3? Let's see. Area 3 is here. This is also another type of 3 versus area 3 is going to be 6a minus a plus 5a minus base over 2 is this. It is area 3. 6a minus a plus this over 2 into a. Both this we have done, top and bottom. This we have found, this we have found, and look at this. So we can say 5a. This this is. There we can say 6a minus 2 base plus 6a over 2 a. Look at this. 6 minus 2 is 6 something plus 6 into this divided by 2 multiplied by this. We got this value. Now area 6. Area 6 is same as area 4. Area 6 is area 4. We got this here. Area 1 is equal to area 3. Area 1. This area and this area are same. So we can say area 1 is equal to area 3, and that's this one taken from J630. That is here, area 3. Okay, then area 2 is here, so just take 600. And total area, all the 1, 2, 3, 4, 5, 6, we get this answer 1, 2, 3, 4, 5, 6. Parameter. You can see a little when it's confusing, or maybe not be confusing, but you have to go into depth of this. Only then you can find this. Now, we're talking of parameter. One is external and one is internal. External, internal here. One is this, and one is this. Right. External is same. You can say 5A, 8A, 5A. 5A to 5 like this, you can say. So 5A. You can say 5A. 8A, 4A. Whichever direction you can take. 5A, 8A, 5A. H, and let's say 6A. H in total. 80, 5A. And this one, this one, this. Similarly here, this one, this side. 2, let's say, this dimension, like this dimension plus this dimension plus this plus. So it says that this is good. 5A, 8A, 5A, H, 6A, H. And if you take this 5A, 6A, H, we have all, and this is sum of that. Sum of these, this is internal, external. We have external, depth is 10, and we can simply say that volume is total area. Total area is area, this is area, multiply by depth to get this one. Okay, this answer. Now internal, we have here. Triangular base 4A minus triangular base 6A, 4A minus triangular base H1, 6A minus twice base H1, and total is there. So this is all that you can see. So both parameters are this, both parameters. So extrusion is how much? Surface area into 2. Surface area equal 2 into end areas and this. So 2 into end areas plus this, you can say, into 10, J360, and the test, you get the answer this. So this is over. Letter E. Letter E. Letter E. You see, it takes time to work out these calculations. A lot of time it consumes because first I have to draw on AutoCAD or JetCAD, then I have to use it there. Then we have to come out with on Excel. It is a little time consuming. Letter E. Is that? No? Letter is this. You can see 4 areas. 8A, 5A, and this is 5A, and this 2.5A. So it's like that. So we say step width is this, step width. And we have area 1, area 2, area 3, area 4. Area 1, 4 into A. Area 2, 8 into A. Area 3, 4 into A. Area 4, 4 into A. This is that. Sum of these areas is this. You got it? You know this. I got this. Now, we have to take care of parameter. In that case, we have to see how many lines are here. We have to take proportion of these into our case. Say, all these lines we have to measure and then sum up. So why is that? You can take case of this. That it is 5A starting with 5A, 8A, 5A, 8A, 5A, A. then 4A, 2.5A, 4A, A, 4A, 0.5A, 4A and A. We have to use these formulas to here like this. We are done. We have to work out formula here. Its values here. That's here. Already done here. And we have to see that. And it is all. I'll show you variables later on. So here is sum of all this is that sum of all these dimensions or calculated dimensions, and we sum it up. When we sum it up, we get perimeter. So we have area and perimeter. Now 3D extrusion. This is area into height, depth, and this is this area of 2 in plus perimeter into depth. You got this. So area of E and letter E is over. This is how fast we are moving. We are moving excessively fast because template is ready made. I'm just explaining to you how it is done. If you make yourself, you will take time. I don't want to waste time by making video long. Just showing during working, so it takes a lot of time. Now F. Well, F is a part of E, you can say. F is a part of E here. You can get same without any problem. So 1, area 2, area 3, and we have to add these areas. 4 into A, 8A into A, 4 into A. You can enter these values, 4 into A. And then we can get our values answered. Not only answered, value. We can get our worked out values worked out very well based on this input. This input we are getting. So area 1, area 2, area 3, and that's 4A into A, this is 8A into A, this is 4A into A, and total is this. So it's not difficult. And similarly, we are here to find these individual dimensions. Individual dimension of this F, that is very important one. 5A, 8A, A, 3.5, 4A, A, 4A, 2.5A, 4A, A, and sum of all sides. So similarly, we give values here. Parameter like dimension 5A, 8A, A, 3.5A, 4A, A, 4A, 2.5A, 4A, and A, and then sum of all. So we got this, and then extrusion is 10, and we can say area into extrusion is volume, and surface area twice into, so it's plus perimeter into depth. We got this salt. We got F salt. Now G. First, what is G? Let me show you what is G. This is G. I'm not taking circular one, I'm taking just a straight. Circular later on, not now. So 1, 2, 3, 4, 5 areas, and this is A, base 1, 8, 5, 4, A, like that. So let's see what is same procedure but different way. Area 1, 2, 3, 4, 5. The 5 areas. It's an interesting one to work like this, The 5 areas in area is 4A, 4A into A, 2 is 8A into A, 3 is 4 into A, 4 is 2A into A, and 5 is 2A into A. So 4A into A, 8A into A, 4A into A, 2A into A, 2A into A. And we got 1, 2, 3, 4, 5 plus. This is all that we got in, right? So over next one, let's see. Parameter 5A, 8A, 5A, 4A, 2A, A, 2A, 3A, 6A, 4A. We just worked out them individually. So this is 5A. Maybe something wrong, I think so. D56, 656. Hold on just a sec, maybe something wrong with this. 5A can be, this is 5 into D 656. 656 is actually its area. I think 58 is, I think, some error in this. I'm explaining to you how. I'm saying 5A actually. This cell is wrong. So what I should, no problem, is D. We have taken, actually, it is, because A is here, so this is not D. This is, you can say, here you take like this, and that will be right. So similarly here, I think there is an error. So this is A, so we take A here. I'm just telling you how error can be caused. Maybe I did not notice at the time of working, so no problem. We are working out and we are trying to see how it works. Everywhere it's also okay except parameters. So this is 5A. A is here B656. So 8A, 5A, 4A, 2A, A, then A again, 2A, then 3A, then 6A, 4A, and then 420 is sum and extrusion. Extrusion for area, that is where area is H656 into 10 SAs, so we got volume here and sum of all sides. Now this 2 into, and what's area? Let us see what's area is. 2000, so it's okay, fine. Now you say area is, now this, and surface area is 2 i's and parameters plus this value. This is V 656 multiplied by this and get this value, and we just be sure about end that 2 into end area plus parameter this end area is H656. Let's be sure of this H656. That's okay, fine. So let's go to letter G. It was right. Letter G. So I'll go to letter H. Letter H. Letter H. This is for you. Letter H. It's difficult actually. It's the easy one. Just easy one like others. Just hold on, please. Very cold. Very cold. Very cold. because my leg is paining. It's a problematic with me. Help me. Just walk few steps in between, say half an hour, because I can't sit with pain. Just to stretch my fractured leg. A little walk, 5-10 steps, just to heat it up. Excuse me for that. So H here, 1, 2, 3 areas. This is 3.5A, this is A, this is 8A, and this is 3A. So we can simply go back to H. Area 1, 2, 3. Sorry. So it's area 8, 8A into A, 3A into A, and 8A into A. So this is 8A into A, 3 into A, sum is here 1 to 3. And we got parameter, we can say A, 8A to A, 3.5A, 3A, 3.5A, 8A, 3.5A, 3A, 3.5, and then sum. So we can just say calculations looks okay. A is 10, 8A is 80, A is 10, 3.5, 35, 3 is 30, 0.5A, A, like this. And we can say sum of all is H to this. You can say H to this. H is here, start of this parameter. So we can say it's okay, 400 or whatever it is. And this is 3D. Volume is area into this. And area is A, 1900. So it's okay, 2 and into parameters, 2 into F662. Is F662 area that you'll see? Yes, this F662 is area, that's right. So we can say F662 into parameter, that's this area, this is period, this is T662, this parameter, into U, this one, the gas. So H is done. H is done. Okay, H is over. We have affected H. We have affected H. I have, I have just few more. Let me finish today. I'll work again on that. And just H. Now I get to I. I, J, and I think K. But this is J twice, however, but this is K actually, not J. I'm sorry. This is K, it's not J. So I'll take K, this one. And I'm not taking any further. I'll do it tomorrow. So let's say J. I. This is your I, you can say here. This is your I. You may say just put like this. You may say this is 5A, area 1, 2, 3. This is A, this is 6A, this is 2A. And we can now count on. This. Let us say I, area 1, 2, 3. And that is 5A into A, 6A into A, 5A into A, and sum of this is that. So 5A, 6A, that. We got this one, so simple. I will go down to parameter 5A, A, 2A, 6A, 2A, A, 5A, A, 2A, 6A, 2A, A. And if we go down now for its dimensions, we'll find here B662A, then 8A, A, 3.5A, 3A, 3.5A, A, 8A, A, 3.5A, 3A, 3.5A, and then sum. H662, S662, 2 here, S662, we got this parameter. Now, extrusion is 10 or whatever, where volume diameter is area, that is F662 as usual, F662 here, and we get answer here, F662, this value, and surface area is twice, and F662 twice plus this value T662 into U6, we got answer. So I is gone. See how fast we are moving. Okay, then I is here, right, I is gone. 3, so we got this here, so we got all that, so this is gone, this here, we got this here. Now J, what is J? You have to see what is J. This J is here, it's nothing very risky, it's okay, fine. So we can say here 1, 2, 3, 4, 5 areas. You can see this 5A, this 8A, and this is 5A, and this is 4A, 2A, and this 1A, A. So we just consider as it is, we'll find J. Area 1, 2, 3, 4, 5, and sum of this. What is area 1? 5A into A, 2 is 6A into A, 3A into 3A is, area 3 is 5 into A, area 4 is 2 into A, area 5 is 2 into A. We can say 5A into A, you can say 6A into A, 5A into A, 2A into A, and 2A into A. Sum is this. We'll take our 5A parameter, A, 4A, 6A, 3A, 2A, A, 2A, 5A, 4A, 5A, and then sum of this. So let's see how it works. Let's say 5A, A, 4A, 6A, then 3A, 2A, 8, 1, 10, 8, 10, I mean to say again 20, 22A, 4A, 5A, 8A, and this is sum is 40, and extrusion is this for 3D, and you can see area is 6 and 4 and W. So let's say H 6 and 4 is area, not less than H is area, is okay, fine, area is this, and we can say R is 2 into S6 and 4 plus V, let's say, into height depth. So we got J done. Now comes K, which is a little complicated one. K is here. You can see first of all how it will behave, how it structurally behaves here. Is what K is about. You can say it's an angle, as in the triangle figure 1, 2, area 1, 2, 3, area 4, area 5, because it is complicated. I did in this case, I did not proportion directly, I proportion indirectly. First I got this measurement from AutoCAD, and these dimensions. And this is A. You can see more and more clear. Here we have rectangle, we have trapezium here. This trapezium, we have this trapezium here, and we have this triangle. Got it? Again, this is one rectangle. The second rectangle. Trapezium. This is triangle, and this is, this is trapezium, and this is triangle. So we have areas as such: 1, 2, 3, 4, 5. What I did, these proportions which I'm getting here, I want to keep this design for all changes. So what I did, this only A relation can be there, but I divided all this by 10 while converting to A. For example, it's 46 point something. I have to get 4.6 something, 6.4, because this is 10 here. 6.4, like that I have converted this. Just for information. And here is that. What's here now? It's that. Step is same, 10. Area 1, area 2, area 3, area 4, area 5. 1 is straight away, there's no doubt in that. It's clear. 18 to A. Area 2 is different. It's trapezium. Trapezium means this dimension 6.4 1.85a plus 1.414a plus a plus 4.657a whole division sum up by 2 because this is the dimension of both sides and multiplied by a, so we got this area. Area 3 is also a triangle. It's a half base into height, half area into height is 0.414. We got this area 4 triangle again, and area 5 is another trapezium. Sum of these both sides over 2 into this, and we got these values here. You can see we got these values of rectangle size, and we got these values of trapezium. That is, this into a plus this into a plus this into a directly a plus 4 into this a, and over 2 by 6 8 1 is a. We got this area. Triangle is half into base into height. We are adding this area. Then triangular area half into base into height, same, and trapezium again we are adding this value. This trapezium here, sum of 2 dimensions over 2 into this, and total area is this. So it's so easy, you can find it. Now we say here I'm going to out parameter a 8a, a 2a, 1.414a, 4.234a, a 0.414a, then 4.657a, a 0.45a, 6.45a, say 4.526a, and sum of all these. I'm just showing you. This is a 8a, a 2a, 1.41a, 4.234a, and then a 0.44a, 4.657a, and this is 4.658, and a and 0.414a, 6.485a, 4.56a, all sides 680, J 680, W 680. This is W and J. Where is J? Let's see. Right or not? And J is A, so it's right. So we got this parameter sum. Now 3D, this area H680. H680, here is H680, there's some areas. We got it here. This we got volume and 2 end parameters 680, and also we got here and here by Z. We got this K. Now what is purpose of this? Purpose is not these dimensions or these quantities, but purpose is changes. I want this 20 say 20, so everything changes. That's the only beauty of this. My control point is here. My control point is here, If I make it 50, it changes. Everything goes. If I make it 5 rather, okay, it becomes this. I make it 25, it becomes this. I make it 10 now. What is now? This is this one. Similarly in J case, I say 13, I make 12. You got this. I make 25, you got this. I have 45, 75, or whatever. You got this. Or I make 10, you got this. It's not only for this, for all, let's say this, letter 15, you got this, 13, you got this, 100, you got this. So this is what I say is required. Same way, all these dimensions can be changed here, say 60. Let us say 60, it changes. Undo this, it becomes same. So that's what purpose is, and I can say that's what engineering says required is automation. And likewise, you can say all dimensions can be done this way. All dimensions can be done this way, and that's where we applied. You can take any one. Let's say D. Let's say D. Okay, D is 15 here. That means 15, and we got this value. angle is not changing, see there, angle is same, where 35, see, 35, see, we got this, same way here, if I see 25, we got this value, if I was 50, we got this value, now I want to come back again to 10, I can come back to it. Same way is B here, that's in 19, okay, you got this value, let's say 60, we got this value, let's say 11, we got this value, let's say 200, we got this value. So we are also here that I say in this diagram of star, in this diagram of star, I don't know reason how that star. I saw this on the yes, right, okay. Automotive, that is okay, automotive. No, this was actually based just a combination of these two templates, that is isosceles triangle and rhombus in this case. This is isosceles triangles rhombus combination, which are done here for this purpose. we go to now where it was before, trying to find the modifier. This modifier I'm trying to find, I'll show you changes in this, how to changes in this modifiers. Let's base is here, so we may say that base is here, we can make it 10 as well, or doesn't matter, no, base is 10, base is here over 2, and base equal to A, so we got a 5 here, we got something changed, you can see that, we can say 25 here, we can change, so it's like that, and you can see that it's working as usual. I say change it here and come back to the other one. This motif, and we've done previously one. Now I have other figures also, letters also. K, after K is L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, like that. I'll take them one by one and put them here, and then also I take inclined letters. For example, A I've taken a square, but I'll take with this fixing dimensions and proportioning. A, K I've written A, and for example, you can take B also in a fashion of curved B, C, and D. G, yes, J, of course, we'll see how can be done, because we want to reach as accurate as possible on complicated figures. That's the purpose of this talk on mathematical proportioning of what we say we should do in calculation expertise or in formula expertise. Already many templates have been worked out which are very useful once you try to grab them, and you can produce your own also without any major problem. I'll show you again certain sketches where it's very important to understand what I'm doing and what's the sole goal of this. Maybe some people saying wasting time, playing time. Yes, you may say that. You have full right to say anything, but remember, if you work on yourself, it's not easy. It's really time-consuming, cumbersome, and it requires full knowledge, concentration, and spend energy on that activity. It's a very important one from your professional point and otherwise. Professional point and otherwise, very important one, and we should come here and find out solutions along with. You can see we have already discussed swastika and cruciform, and we have discussed this David or Shakti, and we have discussed with many connections of this, and then combinations of swastika and cruciform, and then it's like that. Here again line work of strip of Shakti or David, and here swastiks within swastiks, and we have done this, hexagon, David again, and star sign. Stars are important from many people around the world. It is here. So this is what we said. As I said, strip of star, and here letters A, B, C, D, D, E, F, G, H, I, J, K. This is where I done, and that's really very, you can say, it generates some interest. Sometimes you feel it's whole waste of time. Yes, you can say it's waste of time. But once you immerse yourself in this, you'll find something is different. Of course, something is different. It's for everybody to understand this. Something is different. Sometimes what we do, it doesn't mean that everybody does it. What we do doesn't mean everybody does it. And it's also no meaning that you should do that. It's not essential. But you should know, if you do it as the time comes, you have to do it. You'll be able to do that. And you remember, in this case, I talked long back about some formalized automation of this, countings, etc. You remember that time. I have deleted most of that. It's all these formula procedures that we do it. Well, I'm not saying that actually you see here, though you may be feeling now that it's too easy. Yes, it is easy if you understand common procedures which cannot be defined somewhere on worksheet. As we know, we started from where? You can say we started from here, this formula generation, validation, and we did many activities on 4th, 15th, and many days. With this, I don't have records of this, and I was put URLs of past few videos on this text URL, on this text of URL. I'll put other URLs as well. You can just watch them if you find time necessary them for you, or if you're interested in that. I'll try to work on LMNOPQRST VWXYZ. If I can do it, if I could do it fast, fine. Or you can say, let me just operate this correctly. You can say that I will give ranges name also. Them see something is not nice here, so I'm just formatting it that way. So it's okay. So it happens because everything cannot be edited every time. I have to check that all the time. I want to go right. I think you'll find some interest in this type of calculations. Actually, these are not calculations, this is formula design. How can you design based on requirements, based on your procedure, your method, your understanding. There's no hard rule or fast rule on this. It's up to you if you can do it, and if you can do it, fine. And I hope this will work for you in your callings, in your careers. If you are interested to work on computations, this is just, I'm not saying what I'm given is only for you. No, it's not that. It's just the method I'm giving you, how to use cellular system that's been inculcated, infitted, you can say that's been inserted or included in logarithm of worksheet, and it's not very different. It's easy once you understand, because you have to design your format once, your you can say template once only. That can be used whatever number of times you require it. It may be used one time, two times, or 50 times, or 100 times, or million times, or unlimited number of times. And you can copy it. You can paste it somewhere, provided your system is independent, your file is independent. Copy is not recommended, but cut and paste, or you can say move, exactly. You can do that, which is very, very useful from point of view this, and moreover because this formula is very useful in engineering or whatever business you are, where quantities are required, where parameters are required. I can use them directly. These are regular shapes I'm giving. If you do it continuously, you'll find many more development of templates. In addition to 1, 2 is A, B, C, D, could be 1, could be 1, 2, 3, 4, or could be something else. I'll share with you some engineering layouts also later. Layouts means, you can say, township layouts. Township layouts. It's not a joke. There's no joke as such. That is creation. That is creativity, you can say. Creativity of skill. When skill comes into play, you can say application of mind works, and mind works as well. It creates activity of mind to many times than otherwise. No random work is needed if we systemize into something very concrete. I'm not speaking very fast because this work is different. It needs concentration on doing homework, and then to explain to you how this work has been done. Sometimes patience pays, sometimes rapid work pays, both ways. Once you get such formulas available, such templates available, such applications available, you can just enter value of variable and instantly you get all other answers, all other results immediately. If your formula is really reliable, which depends on your work, which depends on yourself or whoever does it. I just tried to apprise people how to create such applications, because once you have application, you can do whatever you want. It doesn't matter whether I have included that or not included that. If you can understand geometry and mensuration, trigonometry, geometry, mensuration, or something else also in addition to that, whatever formula you want to convert to, best ways to understand that one step by step. Maybe sometime you do wrong, no problem. It will automatically reflect itself. It will reflect itself automatically, and there's no problem to that one. Its formula is friend of none, is based on cells. And it works for all entries, all input. It works for. It's neither friend of yours nor mine, but it is user friendly. It's not specific friend, user friendly. I think I've taken your time, because these formulas are very useful, reliable, and you try yourself. If you can do something and you find some problem, you can request me through your Facebook or my email that is given on Facebook. I shall not find any problem to that. So with this, I'll take your leave and close this file and share, because I'm not ready for the others. I'm not ready with others here, and I'm not ready with others. So it's really, I'll now stop.